Hey guys, this is Coach Dennis here. I'm here to talk about the most important thing that we talk about the entire school year, which is valence electrons. So everything we talk about from here on out, it'll deal with valence electrons in some shape or form. So let's our topic, of course, valence electrons. Our learning target, I can correctly fill out or fill in electron shells given an element. Also what we call orbitals and energy levels. So shells, orbitals, energy levels, you might hear all three. So yeah, I can correctly fill in electron shells given an element, use what are called Bohr models, and then I can determine the number of valence electrons and the energy level location by looking at the periodic table, which is really easy. All right, so only certain electrons determine chemical properties of the elements. These are our valence electrons. So we have electrons that are found, closer to the nucleus, and then some that are found further away. So the ones that are found furthest away from our nucleus or from the center of our atom, that's what we call our valence electrons. So what makes these electrons so important is since they're on the outermost level, they can actually move from atom to atom and just move and get move really anywhere and do chemistry. So that's what makes them so important, is their ability to move and do certain things. So how do we calculate valence electrons? So we calculate valence electrons by first figuring out, well, how many electrons do we have? So just as a reminder, and this is in your notes for atoms, is our electrons are equal to the atomic number, which is also equal to your number of protons, or the number of protons. So that's how we figure out our electrons. This should just be review. So first you fill, when we are doing these Bohr models, how we do it is we first have a nucleus. So remember that's made up of our protons and neutrons. And then we have what are called orbitals. Sometimes you'll hear them called shells or energy levels, where you find your electrons. So we have our nucleus in the middle, and then our electrons are found on the outside. So the first shell, you can only have 2 valence electrons in it. This is the reason why, if you look on our periodic table, the very first row or very first period, or what we like to call an energy level, only has 2 elements, hydrogen and helium. So our periodic table basically mimics our atoms. So we go to our second shell. So we got it filled up. We had at least 2 electrons. Well, now we have 3 or more electrons. We're going to move to the second shell. So we go to that. That can have up to 8. Well, you look at your periodic table. In our second period, we have 1, 2, 3, 4, 5, 6, 7, 8 total elements. So our atoms are going to be or our periodic table is going to be mimicking our atoms. And then lastly, we'll get to our third shell. Well, we go up to 4, but our third, if you look in in period 3 or energy level 3, we have 8 total elements. Well, if you look, we have 8 total electrons that can fill this shell. And then whatever you have left, we'll fill in the 4th shell, and then just like our periodic table, we can get up to 7 energy levels, but I am not that mean of a person to make you draw out Bohr models of something, that big. You think about it, you get to element, 106, you're drawing a, 106 valence electrons, or whatever it might be. So that, yeah. That could be difficult. So we're not going to really get past the 4th energy level too much. So basically from potassium, calcium on, you won't see much. So here's a little bit of practice. Now, if we're looking at the slides, which when I'm using screencast, it'll not record it. It's weird. So that's why I'm using a PDF. But when we're doing this, so you have your first energy level, which has 2 valence electrons. Oh, first we have sodium. Sodium has the atomic number of 11, so that means we're going to have 11 protons, 11 electrons. So something that they might also make you add depending on what assignment, where you go, what it might be. Sometimes they have you put what's found in the nucleus. Remember your protons and neutrons. So we're already given number of protons. And I'll do P plus like I usually. Don't bother me otherwise. So we have 11 because it has the atomic number of 11. And then our number of neutrons. I'll do NO. And yeah, it looks like no. But number of neutrons, remember you would look at the periodic table. If you look at sodium, it has the atomic number of 11, which means that it has 11 protons. And then its mass is 22.9. So I'm going to round that up to 23. So 23 minus 11, that would give me 12 neutrons. And that should just be review. So in my nucleus, I have 11 protons, 12 neutrons. So I'm going to have a total of 11 electrons. The first 2, they go on my first energy level. So that's filled up. Once we get filled up, we go to the second energy level. And if you notice, when we have these electrons, we always put them in pairs. When we get a little bit later on in the semester, I might bring up why they go in pairs, but you don't really need to know why, not test it over it, but I will go over it eventually. But electrons like to go in pairs. So if you look, we put in 1, 2, 3, 4, 5, 6, 7, 8. So we have 2 in our first energy level, 8 in our second with 10. So that means we have 1 left. So this 1 left is our valence electrons. So this, what just happened there? So this one is our valence electron. So yeah, the one out there, we only have 1. So just a little reminder of protons. Protons, that's where we get the atomic number from on our periodic table for each element. So that number on top, that's where we get it from, number of protons, because that identifies our element. But now our valence electrons, they determine how our atom acts and reacts, what it'll bond with, how it'll bond. So it all comes down, when we start actually doing chemistry, it all comes down to our valence electrons. So atoms in the same group have similar chemical properties. Well, the reason why they have similar chemical properties is because their number of valence electrons. So if you look at the old numbering system, which we do not have up here, but in the classroom I do have, a couple of the periodic tables have the old numbering system. But basically, you can know how many valence electrons each group will end up with, not just by drawing it, but from their group number. So for the first 2 groups, you have, it's pretty easy. So group 1, you're going to have 1 valence electron. Group 2, you're going to have 2 valence electrons. But where it gets tricky is from group 3 to 12, it's a toss-up. So depending on what metal, what version of the metal you have, you can have, multiple valence electrons depending on what type of iron do you have. Do you have iron 2, iron 3? And we'll go over more of that once we get into ions next unit. But just know groups 3 through 12, it can be a toss-up of how many valence electrons they have. So we can't be sure just by the number of groups from it. But groups 13 through 18, you can. So my little trick is you take away the 1 in 13, 14, 15, 16, 17, 18, all those, you take away the 1 in there, that's how many valence electrons are left. So in group 13, take away the 1 in front, we have 3 valence electrons. Group 14, we have 4 valence electrons. 15, 5 valence electrons. Group 16, 6, so on and so forth. So groups 13 through 18, just take away the 1, that's how many valence electrons they have. Groups 3 through 12, you're not going to know exactly, but we'll get into why that is a little bit more next unit. So here's a look at the old numbering system. A lot of modern periodic tables don't have that. I mean, it's kind of been transitioning for the last like 10 years. So, yeah, here, group 1, group 2, group 3, number of valence electrons. The only exception for group 18, forgot to bring up helium, since it only has 2 total valence electrons, and it's considered to be a noble gas. That one only ends up with 2. And if you remember when I talked about how our periodic table mimics our atoms, if you know our first energy level, our shell and our atoms can only have 2 electrons, well, helium's that second one to fill it up. So yeah, here's a little cheat sheet of how many valence electrons in each group. Notice how there's no exact amount in here. That can change depending on what type of metal it is. So yeah, take your time, practice figuring out how many valence electrons each of these have. So if you're looking at boron, boron's in group 13, so it's going to have 3 valence electrons. Helium's our trick question. Even though it's in group 18, for it to have a complete shell, it only needs 2 valence electrons. And if you look at it, it has the atomic number of 2, so it can only have 2 as for its max amount. Oxygen, group 16, so it's going to have 6 valence electrons. Potassium, if we look at him, right here, group 1, he only has 1. Fluorine, group 17, so he's going to have 7 valence electrons. And if you guys notice, these numbers on the side, these are the number of electrons in each shell for these elements. So it's kind of a little cheat too. So if you look at that bottom number, that tells you your number of valence electrons. So like, let's look at carbon. So carbon, it's in 14 or group 14, so it's going to have 14 valence electrons. So with this too, it's kind of going over what I already talked about earlier. So where are we going to find the valence electrons for each atom? Well, it's on the outermost orbital. Well, how do we know which orbital it's going to be on? Well, the periods on the side also indicate which energy level that our valence electrons are found. So lithium is going to have 1 valence electron, and it's going to be found on the 2nd energy level because it's in period 2. Chlorine. Chlorine is on the 3rd period, so its valence electrons are going to be found on the 3rd energy level or shell of our atom. And yeah, because it's on the 3rd period or 3rd energy level, and it's going to have 7 valence electrons. So here's some more practice for you guys. So elements, remember, elements are arranged by number. Groups, you know, all the groups except for your transition metals, so groups 3 through 12, those won't have an exact number of valence electrons, but groups 1, 2, and then 13 through 18, you can tell how many valence electrons they have and where or which shell they're going to be on by which period they're at. So that was my quick little notes over valence electrons. This is the most important thing we talk about all year. Valence electrons will come up all year long. So make sure you understand what they are, how you figure out how many they are, where exactly they are on the atom, and just understand eventually, once we get to it, especially next unit, how they move. So I hope this was helpful, And guys, have a good rest of your day.